Assalamualaikum warahmatullahi wabarakatuh. I want to tell you about myself. My name is Salsabila Putri Tarigan with a number 2010-95-10-17. I want to tell you about power laws in power electrical power. Electrical power is the ability of an electrical equipment to do work due to change in the work and a change in the electric change per unit time. The amount of electrical power carried out by electrical equipment is influenced by the presence of electric voltage, electric current, and electrical resistance in a closed electrical circuit as well as its condition with respect to time. The tree circuit as well as its condition with respect to time. The three electrical equations are the determinant of the amount of electrical power required by electrical equipment to work. Ultimately, electrical power value are generally listed on electrical equipment label to indicate the amount of energy required by electrical device to be able to work per unit of time. Power loss. Power loss are the power loss along the electric current distribution line, which can occur on the transmission side or on the distribution side. This is because along the distribution of electric current using a condition where that has a resistance value in distance or capacitance that is current resistant, so that the current at the receiving end of the conductor will be smaller than the current at the sending end. Distribution system is all parts of power equipment, electrical that distribute electrical energy from substation to the kWh meter at the consumer via the voltage grade, medium and low voltage grade in the amount of power sufficient in irregular usage time but must be relied on for equality and safety distribution. One form of power quality assessment is the value of power loss and voltage drops to occur at the receiving end of a medium voltage distribution line. The maximum not exceeding 5% and the minimum not less than 10%. It can be seen that transmission power loss can be reduced in several ways, including first, raise the transmission voltage, second, reduce conductor resistance, third, increase load power factor. So to reduce power loss, consider if you First, if you want to reduce the resistance of the conductor, the cross-sectional area of the conductor must be increased. Well, the cross-sectional area of the conductor has a limit. Two, if you want to improve the load power factor, it is necessary to install a compensating capacitor. The power factor improvement obtained by installing capacitor is also limited. And the three, transmission loss are directly proportional to the resistance of the conductor and inversely proportional to the square of the transmission voltage, so that reducing the power loss obtained due to increasing the transmission voltage is much more effective than reduced power loss by reducing the value of the conductor resistance. The amount of power loss is influenced by several factors including the length of the channel, the type of conductor, and the diameter of the conductor. The longer the channel through which the current passes and the longer the cross-section of the conductor, the greater the voltage drop and power loss that occur. While the type or material also affect the resistivity value, which will affect the calculating value of power loss and voltage drop. Improving the value of the voltage drop can be done through the selection of the cross-sectional area of the conductor that will be used in the feeder line or medium voltage network distribution channel. Power loss calculation. First, determining power loss on the primary line. Things that must be done include to be able to determine the amount of energy loss in the line, and it is necessary to first know the magnitude of the power loss in the line. To find out the channel power loss, the capacity of each channel must first be known. Because the load density in the load area is certain, in capacity of each channel can be known from the area of the channel surface. 2. If the magnitude of the voltage across the branching point is considered the same, then the magnitude of the load current in all branch lines will be the same. 3. Suppose the resistance between the two branch points is R and the load current on the branch line is I. The power loss will be optional in the line. Okay, that's all about power loss. Sorry if I make a mistake. Wassalamualaikum warahmatullahi wabarakatuh.